Today, we will be discovering the secrets hidden in a heat sensor circuit, going from electric charges, fields, and currents to science of how these components work together to convert heat energy into sound energy. Let's start with electric charge. Electric charge is a basic property of atoms that is measured in Coulomb and is carried in the electric current that flows in the circuit. Depending on the amount of protons and electrons, the atoms are positively or negatively charged. Like charges repel each other, while unlike charges attract. Now let's continue with electric fields. The electric field is the region around an electrically charged particle that allows the particle to interact with other particles in that area by exerting force on them. Electric fields can be drawn through arrows that go from positive to negative charges. And finally, let's talk about the electric current. The electric current is the flow of electric charge in our circuit, which makes it important for us to know how it flows. Electric current is also the measurement of the quantity of electric charges that flows past any point in the circuit per second, which is measured in amperes. So after we now understand the basic facts of electricity in the heat sensor circuit, let's talk about the components of that circuit, such as the 9-volt battery, the transistor BC547, the buzzer, the resistor, and the diode. The 9V battery provides constant electricity by converting chemical to electrical energy, which is then pushed through the circuit using the imbalance of electrons on the positive and negative terminals. The transistor BC547 is basically the switch of the entire circuit, as when the diode breaks due to the heat, electric current flows to the base of the transistor, opening the path between the collector and emitter, allowing current to flow to the buzzer, thus creating the buzzing sound that will be heard. So basically, the transistor is like a commander who reacts after the diode, one of his soldier bases, has been burned down by the fire, thus making the commander sound an alarm through the buzzer. This buzzer is the output area of the heat sensor circuit, which creates a buzzing noise after current flows through the emitter of the transistor. As the name already implies, a resistor adds resistance to the electric current of a circuit, which protects the other components of a circuit from receiving too much electricity at once and thus getting destroyed, making the resistor a vital part of the heat sensor circuit. The diode is polarized and basically the heat detector of the entire circuit. It usually functions as a one-way highway for the electric current that runs through the circuit. However, if a too high amount of heat acts on it, the diode breaks, thus allowing the backwards current that it has stopped to flow to the base of the transistor, which thus allows it to turn on and activate the buzzer. So after learning about each individual component, let's find out how they work together to create a functioning heat sensor circuit. The 9V battery provides constant electric current for the circuit, which then flows through the base and emitter of the transistor, through the diode which controls the current to flow in one way, while the resistor also adds resistance to the current as to keep it from damaging other parts of the circuit that can't take that much electricity. When the diode then breaks due to high heat, the backwards current flows through, which changes the direction of the electric current, leading it through the collector to the buzzer, which then gives a buzzing sound as an output. Now let's learn about energy transformations in the heat sensor circuit. First, the 9-volt battery transforms chemical energy into electrical energy, which is then provided to the circuit. This electric current will then flow through the circuit, if nothing else happens. However, if heat comes onto the diode, it changes the flow of the electricity by destroying the diode and allowing backwards current to flow to the buzzer, which will then transfer the electrical energy into sound energy that is then emitted from the buzzer as the output of the circuit. When building the heat sensor circuit, we encountered one major problem, which was the difficulty of connecting the different components, as we always didn't melt the aluminum properly or melted it off after it already got on. We even accidentally melted the buzzer, forcing us to exchange it with a new one. However, after some time, we worked together with different groups and the building process gradually became easier. This connects to the statement of inquiry, as this experiment contains electric charges with electric fields and currents, which is used in a heat sensor circuit with a variety of different heat transformations that thus allows us to research and find out the relationships between these energies. The heat sensor circuit helps people immensely, as it can be used as a smoke detector in houses, which can save a lot of people by starting to beep when smoke is detected. Thanks for watching. Hope you enjoyed it.